Okay, so the next section is solving each system by graphing, meaning you need to graph two equations, and then wherever they cross, that's going to be your solution. So it's an exercise on actual graphing. Let's start with the first one. So my y-intercept is 1, so I'm going to plot my point at 1. And I know my slope is negative 1 over 1, so I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And I can draw my line now. Okay, and then let's do the other one in yellow. So negative 3 is where I'm going to start. And then it's up 1 over 3. Oh, look at that. It crosses up 1 over 3, but there's no room, so let's go backwards. Down 1 over 1, 2, 3. And now I have enough room. So, oops, I did not graph that correctly. Down 1 and over 3. Okay, now I can graph it. That's a bad line. But this section, or this point right here, the point where it crosses is your solution. So essentially that is 3, negative 2. And this would be your solution. Let's try one more. So first one, negative 2. I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Graph my line. Okay. The other one starts at 4. I'm going to go up 1 over 2, but I can't go that way. So let's go to the left. So down to the left, down to the left, and then down to the left. So it seems as though this is my point where the two lines cross, which I believe is negative 4 and 2. And that would be your answer. Okay, so the next section says solve each system by elimination. We always try to have the same number in order to cross cancel. This is actually easier than substitution. It takes less time. However, I put both of these equations or these types of problems on there just to have a refresher. So let's say the first one, let's do 164. So essentially you're going to be adding these two equations together. And I noticed that the first equation has a negative 5x and the second equation has a 5x. So when I add these, that actually cancels out. And positive 4y minus 5y is a negative y. And then negative 9 plus 5 is a negative 4. Well, if negative y equals negative 4, then positive y equals 4. So this is one answer. But I'm not done because I still need to figure out what my x is. So now you just get to choose which equation. To me, the second equation looks a little bit easier. So I'm going to plug that in. So I get 5x minus 5 times 4 equals 5. So negative 20 equals 5, and this is 5x. Plus 20 plus 20, 5x equals 25. So x equals 5. So now I have my two answers. I have y equals 4 and x equals 5. And the best way to write the solution of these two equations is in a coordinate form. So since my x is 5, I'm going to do 5, comma, 4, and that is my answer. Now, you won't have the same number, the same integer in front of one of the variables all the time. So let's take a look at 168. So 168, I noticed that the 2 and the 10, I could multiply my 2 by 5 and get positive 10, or I could multiply my 5y by a 3 to get a positive 15. So I'm going to choose the first one, the first option, which is multiply the top equation by 5. So I'm going to multiply this whole thing by 5, and that would make it, sorry, not 5, but 10x minus, what would that be? 5, 6, 7, 75y equals negative 150. And the bottom would stay the same. So negative 10x plus 5y equals 10. So now I do have two variables whose integers are the same. I can cancel that. So I get negative 70y equals negative 140. And so y equals 20. And now that I have my y, I can choose either or of those equations. I'm going to choose the first equation, so 2x minus 15y, and I'm going to plug in 20 for my y, equals negative 30. So negative 15 times 20 would be 300, negative 30 and 2x. So now I'm going to move my 300 over. So 2x equals 270, and so x equals 135. And if you want to put it in coordinate notation, your answer for number 168 would be 135, comma, 20. And that would be your answer. Now substitution is a little bit easier, especially if something like 171 comes up. 171, my y is already isolated, so I just have to plug that in. So 3x plus 2y, which is x minus 3, equals negative 1. So I'm going to not cross cancel. I'm going to distribute, so I get 2x minus 6, and then my 3x on the left equals negative 1. So 5x minus 6 equals negative 1. So I'm plus 6 plus 6, I get 5x equals 5. So x equals 1. Now that I know my answer, plug it back in. I know that y equals 1 minus 3, so y must equal negative 2. And if I wanted to write it in a coordinate form, I would write 1, negative 2, and this would be my answer. Okay, back to graphing. So let's start with a 174. I'm going to zoom into that. 174 right here. Okay, so let's start with the top one. Oh, it seems like it's in slope-intercept form, which is what we want. So I'm going to start off with my y-intercept, and it's a negative 5 over 1 as my slope. So I'm going to go down 1, 2, 3, 4, 5 over 1, which is really outside of my graph. So let's go backwards and go, instead of, you're going to go up 1, 2, 3, 4, 5, but to the left. And that would be the same pattern. And then graph your line. Oops, it's actually dotted. So we're going to dot my lines. Okay. And now you have to determine, okay, what side am I going to be shading? This is my point. It says here that y is greater, so I'm going to shade my greater side. So it seems as though my y's are getting bigger. So if you take a look at that middle point where it crosses the y axis, and I'll do it in red. So this right here is my point that I'm looking at. And you have to determine, are these y's getting bigger or are these y's getting bigger? And whichever side you're looking at, that's going to be the side that you decide to shade. So for example, y is greater than, so I know that my y's are getting bigger up here. So anything that is on the right side of this line is going to actually be shaded. Let's try one more. Let's do 175. So again, it's in y-intercept form, so I'm going to add 2, start with that, and I'm going down 1 to the right 3, down 1 to the right 3, go backwards, up 1 to the left 3, and I am going to solid line this equation. Okay, and then I'm going to pay attention where it says y is greater than, so I know I'm going to shade this top section. Okay, and now I'm going to do my next equation in red. So I start at -2, whoops, start at -2. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Oh, it looks to me like it's right there. So I'm going to solid line it as well. And it also says greater. So I'm going to change the color. It's greater. So this is what I'm graphing. Whoops. And your shaded should actually be green. When you overlap, this section should actually end up being green because blue and yellow will make green. So in this section, I suggest highlighters. Highlighters are the best thing because it's a lot easier to see where the two inequalities cross and the solutions that are possible for them. Okay, so I actually forgot to continue with number 175. So let's go back and let me actually erase. It's not gonna let me. Okay. So I forgot to actually do the second equation. So let's start at 2, and then I'm gonna go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and up 1 over 1. Okay, and it's gonna be a solid line. So there's my solid line. And it is less than. So my less than is going to be below this line. Where are my y's less than? All right here. So essentially your mixed section in this particular problem should be, and I should make it purple, should be right about here. This will be the mixed section. Okay, again, let's do one more since it was a little bit confusing. That was my fault. Let's do number 177. So 177, the first one, you start at 1. And then down 2 over 1, down 2 over 1, down 2 over 1. And it's a dotted line. So I'm going to dot my lines and go up. Okay, and I know that y is less, so I'm going to highlight, and my y's are less here, so therefore this side is what is going to be highlighted. Okay, so I'm not done yet. I still got to do my other one. So I'm going to start at -2. I'm going to go down 1 over 2, down 1 over 2, up 1 to the left so that I can go backwards. And it's also going to be dotted. So I'm going to dot my lines. And now I have to shade it so I know that y is greater than. So my y's are bigger over here. So I'm going to shade all of this. So let's shade. And there should be a mixed or an overlapping piece, and I'm going to draw that now. This would be your overlapping shaded area. And again, if you use highlighters, you'll be able to actually see it. If you don't, it'll get a little bit messy. So, yeah. Okay, great. We've made it to exponents. So there's a few exponents. Again, make sure you read through your notes, the Algebra II notes that I have on exponents. anything to the 0 power is going to equal 1. And then when you multiply, you add your exponents, and when you raise to a power, you multiply. So for example, 2 to the 0 is actually going to equal 1. 2 to the third. Let me rewrite that. We'll say x to the second times x to the third equals x to the fifth, but x squared to the third is going to equal x to the sixth. So these are a little bit of your rules. Aside from that, if I had x to the 5 over x3, it equal x squared. And if I had x3 over x to the 5, the answer would be x to the negative 2, or 1 over x squared. And these would be your answers. Okay, so let's do one of the most complicated ones. I'm going to actually make this a little bit bigger, number 184. Okay, so I'm actually going to do PEMDAS first, which is inside. So negative is on the outside, and I actually have x to the negative 4 because I added those two. And then this would be squared over 2x squared y squared to the negative third, all to the second. Okay, so I'm going to keep going. So negative x to the negative 8 over 2 to the negative third, x to the negative 6, and y to the negative 6. And this is all to the second power. So I have a negative, I have a negative and negative. I'm going to move things around. So if it's negative, it goes on top. So I get 2 to the third, x to the 6th, y to the 6th over x to the 8th, all to the second power. And going off of PEMDAS, I'm going to simplify in red. So I have negative 8, and my 6 and my 8 cancel. I get 2 on the bottom and 1 on top, or 0 on top, I should say. So I get y to the 6 over x squared, all to the second power. And then I can actually distribute my power of 2 to every term. So I get 64 y to the 12th over x to the 4th. And this is my answer. Okay, let's try to do one more. I'm going to do number 185, which is right here. And I'm actually going to bring this down. So I have a negative 2x to the negative third, y to the negative 3, all over parentheses negative 2x to the 4th, y to the 3rd to the negative 1 times negative 1. Or negative y, I should say. All to the second power. Okay, so let's do what we can inside first. So I'm going to draw my fraction. I'm going to keep the 2 on top. I know the x cubed is going to go on the denominator. But before I do that, let's do the denominator first, because I know this negative 1 is being distributed. So let's do that to all of those. So this will be negative 2 to the negative 1, x to the negative 4, y to the negative third, times y negative. My top is x negative 3, y negative 3, and this will be all to the second power. So I'm going to bring that down, and I'll change my color to purple. Okay, so I'm going to have my fraction. 2 negatives make a positive, so I'm just going to cancel those out. So my 2 stays on top. This 2 goes on top because of the negative exponent. This negative 3 will go on the denominator. So x to the third, x to the fourth will go on top. Y to the third will go on top. Y to the third will go on the bottom. And then times negative y all to the second power. Okay, so I get 4x to the fourth y third over x cubed y to the fourth, and I'm going to add a negative right here, squared. I'm going to do an arrow. So, moving on, if I distribute this 2 to every single term, and every single term, I have 4 squared x to the 8th, y to the 6th, over negative x to the 6th, y to the 8th. Okay, and I can cross cancel. So I get a 2 on top, a 2 on the denominator, and my answer is going to actually be positive because this negative times a negative will be a positive. So I get 16x squared all over y squared, and that's my answer. Okay, so the next couple of sections, it's on standard notation and scientific notation, and hopefully you've had enough practice with Miss Craig or last year's math class, or the year before, 6th and 7th grade as well. So you always want your standard notation to have a number larger than 1, and then any significant numbers afterwards. So in this case, for number 186, we have 5.74, and this exponent is positive. Therefore, my number is going to get larger. So I'm going to move the decimal 3 times. So 5740, and this would be my answer. If, in fact, the exponent is a negative, like number 187, the number is getting smaller, so I'm going to go the opposite way. So 893, and I'm going to move it 1, 2, 3. That's my decimal. Okay, so my answer would be 0.00893. And that would be my answer. Let's try a few more. Number 188, I'm going to move 1, 2, 1, 2, 3, 4. So 5.51. And did the number get bigger or smaller? It got smaller, so it's going to be 10 to the how many places? -4. Okay, and last but not least, let's try 189. So 189, we'll start with 8.4 times. Did it get bigger or did it get smaller? It got smaller, so 10 to the -1. It only moved 1 place, so this would be your answer. Okay, next section. So I'm not really going to go in too much detail for simplifying these expressions because you are just combining like terms. So we're adding, we're still adding, we're still adding, adding in all of these. So just make sure the only one that you have to really worry about in this case, or in my example, would be that negative, and just make sure you distribute. Once you distribute all of your signs, you can combine like terms and then go from there. So I'm going to do 96 because it seems like the most difficult. So let's start with, well, it's not the most difficult, but it's the longest. Okay, so I get 7m squared. Actually, let's just go back. Because we're adding and there's no subtraction, I can just kind of underline what we're going to be using. So let's we're adding here. So M2, N2, M2, N2, and M2, N2. Okay, so 7 minus 12 would be -4, and -4 and -5 is a -9. So I know this would be -9, M2, N2. And now we are going to do my other like terms, so M3, N4, M3, N4, and M3, N4. So I have 6 minus 11, which is -5, and -5 plus 8 is actually 13. So plus 13m cubed n to the 4th. And last but not least, I have one last term. So 7m4n, and that's the only one. So plus 7m4n, and this would be my entire answer. If you end up doing number 195, you get -9b cubed plus 5b squared minus 5b to the 5th plus 13b to the 5th plus 14 plus 9b cubed. So 9b cubed and 9b cubed cancel. 5b squared is alone. Then I have -5b to the 5th and positive 13b to the 5th. So I'm going to keep my red as 5b squared, and then I'm going to have plus 8b to the 5th, and my last but not least loner, so plus 14, and this would be my answer for number 195. Okay, long division. It's been a while since we've done this. Maybe you did this last year. Okay, so long division, you're just simply going to divide. It's a regular division problem. So let's start with number 202. So I'm going to start with my x minus 5, and then x squared minus x minus 23. Okay, if for some reason our exponents are not in order, put them in order, because otherwise it will give you the wrong answer. So we're going to start off with our first term. So x times something equals x squared. So x times x is going to equal x squared. And then I have to also do it to my -5. So this would be -5x. So now I draw my line. I'm going to change the sign and change the sign. This cancels. So -x plus 5x is 4x minus 23. Now you got to figure out x times what is going to equal 4x. I believe it's 4. So 4 times x is 4x. So let me point. So you're really doing 4 times x, right, equals 4x. And then 4 times 5 equals something down here. So this would be 4x minus 20, and then you are going to change the sign and change the sign. That cancels. So -23 plus 20 is -3. That's a remainder. So 3 over x minus 5, and this would be your full-on answer. And let me highlight that. So, oops. Let's just do it a different color. Let's say we did it blue. There we go. That way you can see. And that would be my highlighted answer. Okay, let's try one more. Let's do 203. So I'm going to start off by doing 6m cubed. Actually, I should start a little bit lower. So 6m cubed plus 26m squared minus 50m plus 21, and then you divide. So 6m minus 4. So now you got to figure out, okay, what 6m times something is going to equal 6m cubed. So the only thing you're missing is actually m squared. So when I multiply this by 6m, I get 6m cubed. And when I multiply that by -4, I get -4m squared. So I'm going to draw my line, change my sign, This cancels. So I get 30m squared and bring down everything else. And then you start all over. What number times 6m is going to equal 30m squared? So I believe it's 5m. So 5m times 6m is 30m squared. 5m times -4 is -20m. And I'm going to change my sign and change my sign. So -50 plus 20 is -30m plus 21. And you start all over. Something times 6m is going to equal 30m, or -30m, so I'm going to have -5. So I'm going to move this a little bit higher so you can see, and change that. So -30m plus 20, and I'm going to change the sign and change the sign. So plus 21 minus 20 is equal to 1. This is my remainder. So I'm going to have 1 over 6m minus 4. And because the 1 is positive, this will be a plus. So my ultimate answer is going to be m squared plus 5m minus 5 plus 1 over 6m minus 4. And I'm going to highlight that in blue so you can see that that is the official answer. And then you're done.